Okay, good morning everybody. Please try to come before 10 so that we don't spend more time going over the attendance, okay? Next time you have to wait if you come after 10, okay? We'll do only 2 rounds next time. So, if I'm not zooming good enough, please remind me, okay? Another thing is, let's try to use full screen. Okay, any experts? Yeah, but this is only width. I want full screen. Okay, I think that this one is better, huh? Yes. So, what did I tell about conductors? Conductors are short circuit. Okay? If we cut a wire and we leave it hanging, it's what? Open circuits. We have voltage sources and we have current sources. Keep in mind, we cannot know the voltage across a current source unless we do a KVL or we know it in advance. So for example, this current source IS has 2 amps, but we do not know the voltage drop. How we know the voltage drop? We need to do a KVL, know the voltage drop across the resistor, and then we will know the voltage drop across the current source. So voltage source, by default, it tells you its voltage. Current source, it tells you how much current. It doesn't tell you how much voltage. It does not mean voltage drop across the current source is 0. That's wrong information. That's a very common mistake. So, true or false? Voltage drop across a current source is always known.
False.
False. We need to spend some effort to know it. True or false? It is always 0.
False.
When it's 0, there is no current. Even though if there is no current flowing through it, it could, in special cases, it could have a voltage drop of non-zero. But rule of thumb is we do not know Vs in this circuit. We need to solve it, okay? That's a very common mistake. When you see a current source, what's the first thing comes into my mind? I need to find other voltages to know its voltage drop. If 2 points are connected together by an ideal conductor, no voltage across the short circuit. For example, there is no voltage drop here, there is no voltage drop across the conductor. Open circuit, no current flow through an open circuit. Question: what is a voltage drop across? So this is example 0. Example 0 means I just came up with it. 5 volts. What's the voltage drop between A and B? What is VAB?
0.
Wrong.
We know the resistance before.
Okay, how much current?
0.
That is correct. Is the voltage drop 0? No, what will happen? There is 0 voltage drop here, but still there is 5 volts here. Let me repeat this example again. A hanging battery, طارية معلقة. You measure the voltage across 100 kilometers away from it. What's the voltage drop? Same as the battery. Okay? So the voltage drop is 5 volt. Get it?
What about the resistance?
The resistance, the voltage drop here, VR is 0.
Okay.
Because there is no current flowing through it. You don't know? Do KVL. Let's do KVL.
There is no closed loop.
So we have here plus, no, we can do KVL. VAB, plus minus. We said VR is here. And we say this one is what? V, let's call it S, from source, equal to 5 volts. So what do we do? Let's start from here. Voltage rise or voltage drop? Drop minus. Voltage rise or voltage drop? Voltage rise or voltage drop?
Rise.
So VAB equal to VS. صح? The minus will cancel, equals to 5 volt. So KVL worked, صح?
But this is not a loop.
It is a loop.
Should this be closed?
Well, it's an open circuit, special loop. Okay? When it's an open circuit, you always say no current flowing. The current has to be, if we close this, what? Okay, if we close A and B, then the current will flow. We'll solve it in a second. But now, open circuit and battery. You know how to measure its voltage? Over experience, once you look at it, you say, okay, no current is flowing here, so the voltage drop here is like this. Get it? واضح يا شباب? Is example 0 clear? Okay. If you get stuck, KVL. Let's say somebody said, I want to connect A and B. And he put a plus, a minus, VAB. Okay? And then, let's say the resistance here is R. So the current here is what? Let's call it I through R. And it moves this direction. Okay? What's the voltage drop across A and B?
0.
Why? Because it's a short circuit. Somebody said, oh no, I don't trust this. Let's do KVL. Let's do KVL. Voltage rise. Let's start from here. Go over this loop. Now again, a loop doesn't have to be closed. It can be an open circuit. What's the voltage rise? Okay, let's start from here. What will happen? Plus VS. صح?
Yes.
Then minus VR. And then minus VAB. We know it's 0, but let's put it in the KVL. Because 0 will not hurt your KVL. Equal to 0. So VS equal to VR, which equals to 5 volts. So the voltage drop across this resistor is what? 5 volt. Let's call this example 0.1. So what's the difference between example 0 and example 0.1? Example 0, we have an open circuit,
And
closed short circuit. So you see what will happen if you short circuit your simple circuit, a current will flow. We will measure this current later in Ohm's law, but for now I want you to know the two circuits, 0 and circuit 0, circuit 0.1. Always keep it in mind, that's the simplest circuit. That's why I wanted to introduce you guys to circuits. Okay? In summary, open circuit will not have a current flowing through it, but will carry the voltage of the battery that's connected to it. And a short circuit will not have a voltage across the short circuit element, but it will have a current flowing through it. Is it clear? في أحد ما هو واضح عنده هذا المثال؟ واضح يا شباب؟ So example 0, example 0.1, rewatch the YouTube video. If you have questions, come and ask me. Then sometimes we have, okay, what we have here is what we call independent voltage sources. It means in this course we will only deal with independent voltage source. It means the voltage source is either DC as a number or sinusoidal signal, 5 times cosine 2 pi t. The only variable that you will have is time. But we still call it an independent. It means independent from the other circuit elements. So we have AC voltage source, DC. For now we're not discussing AC, for now we discuss DC. Okay? So independent of other elements. It still can depend on time by definition. if it's an AC. Okay? Same for the current source. They can depend on time, they can be DC, and they can be AC. What's the voltage drop across a current source? We don't know. What's the voltage drop across a voltage source? It's defined by definition. What's the current that goes through the current source? We don't know. We need to do the math. What's the current that flows the current source? It's already written. Yes?
It's an example of an current.
It doesn't exist in real life. The only example is waveform generator. Current sources are not physical. There is no battery called current source. The only thing is you connect a computer and you generate a fake signal. In real life, there is no current source. Okay? But this tells you the physics behind the circuit. Oh, we're imposing this current somehow by a computer. Is it clear? Now, because we have so much confusion so far, I'm going to skip this slide. It's irrelevant. The only thing I want you to know, if they tell you dependent voltage source, oh, the voltage here depends on the voltage here. Or the current, the voltage here depends on the current there. Same for the current source. Sometimes the current source depends on the voltage source. Sometimes the current source depends on other currents. This is not required in this course. If you want to learn more about it, reach out to me. Okay? Let's go back to circuit 0.1. So what we had is we had a battery of 5 volts. Right? Then we have a resistor of R. Let's call this time R to be 5 ohm. Okay? Then I told you between A and B, we connect a short circuit. What is the voltage drop across AB? 0. Okay? When we did a KVL, what did we say? We say voltage rise, which is Vs, plus Vs, and then we said, now, you can put the sign any way you want, but I told you, if I don't give you signs, put them like that, from left to right pluses, from top to bottom. That's the best strategy, so that you don't confuse yourself. If I tell you the signs, you work with what I told you. Then we have VR. Let's do KVL. Plus Vs. What else? Minus VR. Minus 0, let's drop it, equal to 0. So what is VR? Vs equal to 5. Ohm's law tells you I can calculate the current, which let's call it I sub R, which means I sub R from resistor, the current that goes through the resistor, by the relationship equals I R times R. You already did this in Physics 101. If R is 5, then I sub R equals 5 volts over 5 ohms, which equals to 1 amp. So there will be a 1 amp going through the resistor. Get it? What did I tell you about the impedance R? If we increase it, it will limit the amount of flow. Let's say that R was changed from 5 to 10 ohm. We increase this impedance. What will happen here? We replace this 5 with the number 10 and you will have a half amp. So what do you say? The relationship. We increase the resistance by 2. The current was reduced by 2. So that's what we call it a linear relationship. So there is a linear relationship that the slope of the line, if you increase it for the same amount of voltage, you will get less current. Again, focus with me. You don't need to know it, but If someone told you explain Ohm's law graphically, for the same amount of voltage, if we increase the slope of the line, which is the resistance, we will have less current flowing through the element. If we reduce the slope, reduce the impedance, for the same amount of voltage, we will have more current. And does this make sense with the definition of resistance? Yeah, the more we resist, the less current will flow. Circuit 0.1, is it clear? Okay, let's do Ohm's law for circuit 0. Circuit 0, what we have here is 5 volts. We said we have R equal 5 ohm, and we said we can have it an open circuit. What did I tell you about VR? We said because it's an open circuit, there is no closed path, we still can do a KVL. We did a KVL and we noticed that VAB equals to VS equals to 5 volts. This implies that VR equal to 0 because there is no current flowing through it, which is equal to I times R. So what is I in this case? I is 0. This means because the voltage is 0 across the R, the current is 0. So we're operating at this point. This V is not the source. This V is the voltage drop across the resistor. So this V here, here, here is the voltage drop across the resistor. Is Ohm's law clear? We use Ohm's law to calculate the resistance if we know voltage and current, or calculate the current if we know the voltage and the resistance, or we can use it to calculate the voltage if we know the current and the resistance. Get it? Yes.
What about times?
We'll talk about it now. What did I tell you about the power if we have the current entering through options 3 and 4?
Negative.
You need to add a negative. So option 3 and 4, if the current enters through the negative, remember option 3 and 4? If we have a resistor, now again for option 3 and 4, if we have plus minus, the current enters here, or if we have minus plus, the current enters from here, this is 3, this is 4, then V equal minus. هذه غصب تحطها. Okay? هذه غصب تحطها. But from my experience, once you solve the circuits, you will always try to put the current flowing through the positive and the negative. So always, if I don't give you signs, always when you see a resistor that has nothing on it, you put plus, minus, and you assume the direction of the current to go from the plus and minus to avoid this negative. We will solve examples, okay? So passive sign configuration still works with Ohm's law. Let's do this simple example mentally. V equal 4, R equal 10. Let's say the current enters from the top. What is I? 0.4. صح? This, it tells you 10 ohm. Let's call this 4 volt. Let's call IR. What is IR? 4 over 10 volts over ohm. What's the unit? 0.4 amps. If I say the current enters from the negative, let's call it IR negative. Another current, it's simply minus 0.4. Is it clear? We will reach a checkpoint today. I want to reach this checkpoint because we want to spend more time on the examples than the lectures. But is the concept clear? بالمثال يتضح المقال. Conductance الموصلية. So resistance is the, yes please, question? Okay. Resistance is قاومة. Conductance is العربي موصلية. What's the unit of conductance? Siemens. You all know Siemens company? Siemens Energy. Why they named it Siemens? Because they're scientists. So the unit of موصلية Siemens, which is 1 over R, which is the opposite. For now, just keep it as an idea, okay? If you reverse Ohm's law, you will get I equal GAV. Now we will use this later, but for now, think of R is the reciprocal of impedance, okay? How much I impede, 1 over that is how much I allow. Get it? Now what's the difference between resistivity and resistance? So I can tell the resistivity of glass is a constant feature. We have it in chemistry department. The resistance is how big this water bottle. Get it? If I have a huge water bottle, it will have different resistance. In other words, الريزستيفيتي هي خاصية بالمادة والريزستنس هي خاصية بالكيبل حقك. يعني لو الكيبل حقك نحاس، كل كابل النحاس الريزستيفيتي حقتها واحدة ثابتة. بينما الريزستنس مختلفة حسب الديزاين. For example, if we have a wider cross-sectional area, you will have less resistance. If you have a longer cable, very long, you will have more resistance because more object would resist the flow of electrons. Get it? So the way we calculate it is using this equation. I'm not going to spend much time about it. We have 3 types of conductors. وعندنا الموصلات، أشباه الموصلات، والعوازل. Think of conductors as the lowest resistivity. They allow current to flow through the circuit like copper, aluminum. What's the best conductor? Expensive ones? Gold. We wish to have transmission lines made of gold so that we can steal it and sell it in the market. صح? صح ولا لا? Well, that's not true because they are super conductors. The middle solution for transmission lines is to have either copper or aluminum. تمام? Then we have insulators, the plastic, الخشب, الglass, عوازل. They have very high resistivity. What about the air? Is it conductor or insulator? Insulators. In electrical engineering, if we have extreme high voltage, we will break the insulation. For example, if you put a wooden rod between a high transmission line cables, it will burn, صح? Even though the wood is not conductor, but because of the high voltage, the resistivity of it is not enough. So electrons will flow through and then the fire will happen. Then we'll have semiconductors, أشباه الموصلات, silicon chips, computers, الجوالات, etc. Okay? In this course, we will deal mainly with conductors. Now, these are the tables. You have, for example, aluminum. What's the unit of resistivity? Ohms times meter. Okay? We have 2.73. Carbon is smaller, is less resistive. Then you have copper, 1.78. Okay, carbon is more. Okay, is carbon more insulator than copper? Yeah. Is copper better conductor than aluminum? Yeah. Okay, how about gold? Is gold better than copper? Yes, because it has less resistivity. What's the best among all of them? Tungsten, صح? Semiconductors, you have silicon, and then you have quartz, glass, teflon that are insulators. You will need this table, and we'll give you a simple problem, maybe in the exam. We'll give you, okay, given what is the area needed to have this R, given this material, given that length? Or what's the length given this area, given this R, given this, okay, what material gives you, so we change one variable. And this is what we did in these examples. For example, In this example, compute the resistance of the copper wire having diameter of 2.05. Quick question. You have a circle. What's the diameter of a circle? قطر. 2.05 times 10 to minus 3, صح? Meter. What is the radius? Divide by 2, صح? What is the area of the diameter? Pi r squared, which is equal pi times d over 2 squared, which is equal pi d squared over 4. That's why we came up with this formula. If I give you a triangle in the test, what's the area of a triangle? Well, there is no conductor made of triangle, but half of the base times the height. Okay, these are one of the tricks we might have in the test. Trapezoidal. Google it, okay? I will make it.
It's 2 times the triangle.
Calculator? We all have calculators like that, Casio, صح? I think it's allowed in the test. Pi times 2.05, 10 to minus 3. Don't forget to convert to meters. Divide by 4. That's the area. Then we have the resistivity. 1.72 E minus 8 times L, 10. Length of 10 meter. Divide by the area, which is answer. So you will get the final answer to be 0.052. Try to solve examples like that, okay? There is a question. What do you expect to get? High or low resistance? Well, it's irrelevant. Depends. So let me ask you a question. Because they love these questions in Physics 102. What will happen if I increase the diameter by 4?
It will be multiplied by 16.
The resistance will be divided by 16. These are the questions, and then we bring them like that. Understand this question? If we double across the diameter, the resistance will be reduced by 25%. Okay? So it's not linear. Any question about this problem? Now, there is another concept, is power, from Ohm's law. Do you remember I told you P equal V times I? صح? Let's say with a positive passive sign convention, so P equal V times I. But I already told you I is what? R over V. Is it true?
V over.
Wrong. V over R, which implies it equals to V squared over R. So this is another formula to calculate the power without calculating the current. If you know the resistance and the voltage, you can calculate the power. So here, another way is VI, which equals to RI squared. One is I square R, one is V square over R. These are going to be very handy when you calculate the power. So you don't need to get the current. Just have, I know voltage, I know R, can get the power. Save time. We save 1 to 2 minutes in the exam. Okay? I'm going to put heart in these equations, okay? Heart means you have to memorize them. Or, I don't care, before you enter the test, you write them on the cover page, okay? I will try to allow formula sheet, because I don't like memorizing. But if Dr. Ahmed or Dr. Atiyah have questions designed to be based on understanding, then we'll probably not allow formula sheets. But I'll do my best, I promise. When the power is positive, it means we absorb, like a lamp. When the power is negative, it means we supply. Okay? Any question about this slide? So a resistor is a two-terminal device. Resistance is a circuit property which voltage is proportional to the current. خاصية في المادة. Resistors have the property of resistance. Okay? Resistivity خاصية المادة. Resistance مقاومة نفسها. Resistor هو نفس element. So a resistor has a resistance which is impacted by its resistivity. فهمتوا؟ resistor اللي هو نفس هذا الشيء مقاومة شكله كده. And the colors here in the lab means there is a map that tells you if it's brown it means multiply by 2, black multiply by 100, red, whatever. So the numbers here tells you the value of the resistance based on the color strips, okay? In the lab you will see, we'll have lab this week.
Yes.
So make sure to attend the lab, okay? And I'll try to visit you. Today we have a lab. What time? 2? 2? With the kursihati, صح? Okay, I'll try to visit you. Now try to do these examples. I'm not gonna solve them because I prefer the checkpoint. You guys love the checkpoint, صح? This is easy. You can calculate it. This is example in the book. Again, you use V square over R. I'm not going to solve it for now, but do you guys want me to solve it or go to the checkpoint? I think the checkpoint is more important. We'll solve this later if we have time. Again, this is like circuit 0.1 except we put the resistor on the A and B terminal, صح? So this is circuit 0.1. So what does that mean? It means if I do KVL, this is 10 volts. The voltage drop here is going to be 10 volts. It means the current that goes from top to bottom is 10 divided by 5, which is 2 amps. If I reverse the direction of the current, it's going to be minus 2 amps. But for now, we're going to keep it 2 amp. So what's the power across the resistor? Is 10 times 2 is 20 watts. Is it absorb or supply? Absorb. Dissipated as a form of heat. Now the voltage source has to supply by minus 20 watt. Get it? So one has to supply the other. Usually batteries supply, but not all the time. You need to go through the process. We want to know the current, the voltage, and the power of each element. Now, this is the same example, but here, analyze the circuit of figure 1.4. This is the same circuit, but we reverse the voltage polarity. What will happen? Ix, you want me to do this example? Let's do this example. Let's do a KVL. Start from here. Is voltage rise or voltage drop? Rise, so plus Vx. Voltage rise or voltage drop? Plus Vs equal to 0, صح? So it means Vx equal to minus Vs. Vs is already known because it's a voltage source. This is a voltage source or a current source? Voltage source. If the arrow is inside the circle, it's a current source. But the arrow here to indicate the circuit, the current that flows here. So that's a voltage source which is equal to minus 10 volts. Now, again, you have a resistor of 5 ohm minus plus. And we have here what we call it Vx. Vx means the voltage from here to here. So the current enters from here, and we call this current Ix. So the formula is Vx equal minus غصب. Okay? Ix, we call it Ix here, not IR. Stick with the notation that gave you in the problem. Times R. So this implies Ix equal minus 10 divided by minus 5, which is 2 amps. So I know Ix is 2 amps. What is Iy? It's the opposite direction, صح? Or we can do a KCL here. N equal out, lower right corner. So what is N? Ix plus Iy equals 0. So Iy equal minus Ix, which equals to minus 2 amps. Minus 2 amps? Iy, صح? So what's the power? Vs is minus 2. What is Ps? Vs times Iy, صح? No negative sign because the current enters from the positive, which equal to 10 times 2. 2 or minus 2? Minus 2, which is minus 20 watt. So this supplies, okay? What is the power across the resistance? The current enters through the negative passive sign configuration. I think that's option 4. Minus Vx times Ix. What is Vx? Minus 10. صح? What is Ix? 2. 20 watt. This what? Absorb. Same results. Even if we change the directions of the voltages and the currents. Okay? Get it? Rewatch all the YouTube videos, guys, okay? Please rewatch it. I know it's difficult to absorb, especially once we do now the checkpoint. You love these things, صح? Let's do the checkpoint. We have 10 minutes left. I would rather do the checkpoint and then we will finish chapter 1. All the other problems are easy to do. Consider the circuit shown. Do whatever skills you learned to calculate Vx. What is Vx? Well, it's V1. That's a mistake in the book. V1 is Vx. Okay. So what do we have? We have 3 resistors and 1 impedance. So we have a battery of, do we know this voltage? No. We have 3 ohm, and then we have 6 ohm, 3 ohm, 3 ohm, and then we have, well, the only information we know is that there is a 2 amp here. Okay? 3 ohm, 3 ohm, 6 ohms, 3 ohm. So let's define a current here. Let's call this Ix. Right? So Ix by definition, then we will have what? VR1. And then we have the same voltage here. Let's call it VR2, which is the same voltage as here. VR3, which is the same voltage as here. VR4. Which one of the V's I can calculate? The last one, VR4. What is VR4?
6.
3 times 2, which is 6 volts. Do we put a negative?
No.
No, because it enters from the positive. There is no passive sign configuration. Okay, this is V, I'm sorry. Okay, what is VR3? Which is equal to VR2. Which is equal to VR4. What is 6 volts? So this is 6, 6, 6. Get it? That's a parallel. You can do KVL, but now you are smart enough to know these 3 resistors are connected in parallel. So if I know this, I can do a KVL across the left loop. Let's do a KVL across the left loop. We have here Vx, we have here VR1, we have here VR2.
VR1 is 0.
I still need to know the current. صح? But I know the voltage here, I know the voltage here, I can know the current here and the current there. So, let's define this to be IR2, IR3. So what is IR3?
minus V over 1.
There is no minus, Shabab. Why we put a minus?
Because when we make a loop, it would be.
I know the voltage here. I know the impedance. I can calculate the current that goes through here.
But if we take the left, the rightmost loop, it will be negative 2.
This is 2 amps already. This is I know the current here is 2 amps. This will be 2, this will be 1. Because we're going to do a KVL across the elements. So what we have here, IR2 equals VR2 divided by 6, صح? Which is 6 divided by 6 equals to 1 amp. And IR3, which is the current, this is IR1, IR2. Or IR2, IR3, sorry. IR2, IR3, IR4, which is 2. So what is IR2? 1 amp. IR3 is VR3 divided by 6 or 3, which is 6 over 3, which is 2 amps. So I know this is 2 amps, this is 1 amp, so this is 2, 2, 1. We can do a KCL here. So KCL at upper central node. N equal out. What is N? IR1. What is out? IR2, IR3, IR4. We will repeat this example, which is going to be IR2 plus IR3 plus IR4, which is 1 plus 2 plus 2, which is 5 amps. So now I know the current that goes here. So I know the voltage drop here, the voltage drop here. I only need to calculate the voltage drop here. And now I'll finish it and we'll repeat it real quick. Now KVL around. The only loop we need is this left loop. So we have Vx, we have the 3, we have the 6. Here, it's irrelevant. So what's the voltage drop here? 6 volts. What's the voltage drop here?
15.
VR2 equal 5 times 3. That's IR1, I'm sorry. VR1. What is VR1? 5 times 3, which is 15 volts. So do a KVL here. Voltage rise or voltage drop?
Drop.
Minus VR1. Voltage rise or voltage drop?
Drop.
Minus VR2. Voltage rise or voltage drop? So what is Vx? Vx equals VR2 plus VR1, which is 15 plus 6, 21 volts. If you check the solution manual, you will find this answer. Yes, please.
على أي وين سويت KCL؟
We did the KCL here.
كيف؟
In IR2,
Okay.
out, in IR1, out, IR2, IR3, IR4.
Oh, I have bought. Just now, I have.
Out of the node. You're talking why we did not calculate the current here. Well, the current here is IR3 plus IR4. So let's split them again. Get it? That's a very good question. Yeah, here it's IR2 plus, I'm sorry, IR3 plus IR4. So IR3 plus IR4. So let's just say IR3 plus IR4. Let me repeat in a nutshell how to solve this problem. We already have 2 amps here. 2 times 3 is 6 volt. No negative sign. That's 6 volt, that's 6 volt. The current here is, this 3 ohm, 3 ohm, the current here is 2 amp. The current here is 6 divided by 6, which is 1 amp. 1 plus 2 plus 2 is 5. So the current that goes through the upper R1 is 5. So what's the voltage here? 6. What's the voltage here? 5 times 3. What's the voltage here is V1 minus VR2 minus Vx or V1 minus VR1 minus VR2, which is going to be to the right hand side 15 plus 6. That's how we got the 21. Time is up. If you want to leave, you can leave. Any questions? We finished chapter 1. Try to solve these problems at home. These are very easy problems. If you have questions, and solve the checkpoint. Solve the checkpoint, guys. Okay? Is the problem clear? Any questions? Attendance, those who came late. Any questions? Please ask. Come to the office if you have questions. Call me on Teams anytime, 24/7. Customer service, 24/7. تحضير عارف تحضير.
بس شو الزنا بس.
Let me stop the recording. Questions about the material?
Office hour. في office hour.
I'll do my best, yeah.